In the 1930s, a Swiss astronomer named Fritz Zwicky observed a distant cluster of galaxies called the Coma Cluster. He measured how fast the galaxies were moving. The speeds were unusually high. Based on visible stars and gas alone, these galaxies should have flown apart and disappeared into space. They did not. They remained bound together, moving in a stable and repeated pattern. This was the first widely recorded case of a large-scale motion that did not match what the visible matter could explain. The same type of strange motion appeared again decades later. In the 1970s, Vera Rubin studied how stars move inside spiral galaxies. She found that stars far from the galactic center were moving nearly as fast as stars near the center. This behavior was consistent across many galaxies. The pattern repeated again and again. According to ordinary gravity, outer stars should move more slowly, similar to how distant planets in a solar system travel more slowly than those close to the Sun. The observed behavior did not follow this rule. A simple everyday example explains the tension. Imagine a carousel in a foggy park. Only the edge of the platform is visible. If the outer seats spin just as fast as the inner seats, something unseen must be adding weight to the center. Otherwise, the structure would break apart. In space, light from stars plays the role of those visible seats, revealing motion that cannot be supported by visible mass alone. Over time, astronomers began to see this as a repeating structure rather than a local mistake. Galaxy clusters, spiral galaxies, and even large cosmic regions showed the same behavior. Light from distant objects was also observed bending in space more than expected. This bending, known in simple terms as light being curved by heavy mass, suggested a widespread gravitational influence that could not be seen directly. These observations formed a growing hint. The universe contained a large amount of unseen material. This material did not glow, reflect, or absorb light in any noticeable way. It interacted mainly through gravity, the force that causes objects to pull toward each other. Scientists eventually gave a name to this hidden framework: dark matter. This concept explained why galaxies stay intact, why clusters remain stable, and why the large-scale structure of the universe holds its shape. The strange motion was not random. It was a visible signal of an invisible mass woven through space, shaping movement and structure on a scale far beyond any single star or galaxy. Invisible mass is the idea that galaxies are held together by material that cannot be seen with ordinary telescopes. This material does not shine like stars, and it does not glow like hot gas. It only shows its presence through gravity, which is the force that causes objects to attract each other. In visible space, stars and gas create light. Scientists can measure how much matter exists by measuring that light. When they compared this visible mass to the motion of galaxies, the numbers did not match. The galaxies were moving as if they were much heavier than what could be seen. This gap between what is visible and what is required for stability revealed the presence of unseen mass. A simple daily example helps explain this structure. Imagine a sealed box filled with magnets. From the outside, the box looks empty. When a metal ball is rolled near the box, it changes direction and slows down, as if something inside the box is pulling on it. The movement of the ball shows that something real exists inside, even though it cannot be seen. In space, stars and gas clouds act like that metal ball, responding to invisible gravitational pull. This hidden mass forms a large, extended structure around galaxies. Scientists describe it as a halo. A halo is a wide, spherical region that surrounds the visible parts of a galaxy. It can stretch far beyond the bright spiral arms and luminous centers. This structure does not collapse or drift away because gravity keeps it stable over billions of years. The natural phenomenon behind this stability is gravitational binding. Gravitational binding means objects stay together because their combined gravitational pull is stronger than the forces trying to separate them. On Earth, this same principle keeps the Moon in orbit and keeps the oceans held to the planet. The historical discovery of this invisible mass changed how scientists understood the universe. Before this idea, it was assumed that light showed most of what existed. After repeated observations, it became clear that most of the mass in galaxies could not be seen directly. This invisible component acts as the main backbone of galaxies, quietly shaping their structure and keeping them intact across cosmic scales that span hundreds of thousands of light years. For much of modern astronomy, scientists assumed that visible light revealed most of the universe's matter. As measurement tools improved, careful observations began to show that light alone could not explain how large cosmic systems moved and stayed together. The galaxies in this cluster moved so fast that, based only on visible matter, the cluster should have broken apart. The gravitational pull from the stars and gas was not strong enough to hold the system together. The cluster remained intact, which showed that some additional source of mass was present. Later, in the mid to late 20th century, detailed studies of spiral galaxies added further evidence. Vera Rubin and her collaborators measured rotation curves, which are graphs showing how fast stars move at different distances from the galactic center. According to basic Newtonian gravity, the speed of stars should decrease with distance, similar to how outer planets in the solar system move more slowly than inner planets. Instead, the rotation curves of many galaxies remained flat. Stars far from the center moved just as fast as stars near the center. An everyday comparison illustrates this conflict. Consider a city map at night that only shows the locations of streetlights. The lights suggest where most of the people and buildings might be. If traffic patterns show strong activity in areas with few or no lights, then the visible map is incomplete. Hidden structures such as tunnels, unlit roads, or underground stations must exist. In the universe, light from stars plays the role of the visible map, and the motion of stars and galaxies plays the role of traffic. The mismatch between light and motion revealed a hidden component. The natural phenomenon behind this mismatch lies in gravity. Gravity depends on mass, not on light. If objects move as if more mass is present than can be seen, then either the law of gravity changes on large scales, or there is unseen mass contributing to the gravitational field. At galactic and cluster scales, the consistent pattern of extra gravitational pull pointed strongly toward the presence of additional matter. Gravitational lensing added a final layer of evidence. Light from distant objects bent more than visible matter could account for. Across galaxies and clusters, motions were too fast and structures too stable. These repeated patterns led to the conclusion that most cosmic mass is invisible, a substance now known as dark matter. Gravity is the force that causes objects to attract each other. In everyday life, it is what makes objects fall to the ground and what keeps the moon moving around the Earth. In space, the same force controls how stars, gas, and entire galaxies move. In deep space, however, gravity does not always behave in ways that match what can be seen with light. When scientists measured how fast stars orbit inside galaxies, they expected a pattern similar to the solar system. In the solar system, planets that are farther from the sun move more slowly because the gravitational pull becomes weaker with distance. In galaxies, this slowing did not appear. Stars far from the galactic center moved at nearly the same speed as stars much closer in. This flat motion pattern appeared again and again in different galaxies. A simple daily comparison makes this easier to imagine. Think of a playground. If a child moves farther away from the point where the swing hangs, the pull from the chains becomes weaker and the swing becomes unstable. In galaxies, stars far away should feel weaker attraction and move more slowly. Instead, they moved as if a much stronger and wider source of gravity was present. This strange behavior of gravity also appeared in galaxy clusters. Clusters are large groups of galaxies bound together by gravitational attraction. The galaxies inside these clusters move too fast to remain bound if only visible matter was providing the gravitational pull. The natural conclusion was that additional mass existed, spread throughout the cluster, adding to the gravitational strength without adding visible light. This pattern revealed a fundamental truth about space. Gravity responds to mass, not to brightness. If gravity is stronger than expected, then more mass must be present than can be seen. On galactic and cluster scales, this extra gravitational effect became one of the strongest signs that the universe contains a vast amount of unseen matter, shaping motion and structure across distances measured in hundreds of thousands to millions of light years. Dark matter is the name given to a form of matter that does not produce light and cannot be seen directly with telescopes. It does not glow, reflect light, or block light in a noticeable way. Its existence is known only through its gravitational effects, which influence the motion of stars, galaxies, and large cosmic structures. To understand what this means, it helps to define ordinary matter first. Ordinary matter is made of atoms, the basic building blocks of everything visible. Atoms form stars, planets, gas clouds, and living beings. This type of matter interacts with light, which is why it can be photographed and measured by telescopes. Dark matter does not behave like this. It does not interact with light in the same way, which makes it invisible. A simple everyday comparison can clarify the difference. Imagine a clear glass window on a dark night. If a strong wind pushes against the glass, the movement can be felt even though the wind itself cannot be seen. The force is real, but the source of the force is invisible. In space, gravity plays the role of that pressure. The movement of stars and gas shows the presence of an unseen source of gravitational pull. It is important to understand what dark matter is not. It is not made of normal gas, dust, or hidden stars. It is not black holes spread everywhere. Those objects interact with light in detectable ways. Dark matter is also not the same as dark energy, which is a different concept linked to the expansion of the universe rather than gravitational structure. The natural behavior of dark matter is simple but powerful. It responds to gravity and creates gravitational fields of its own. These fields guide how galaxies form and how they remain stable over billions of years. On a cosmic scale, dark matter acts as an invisible framework. Normal matter falls into this framework, forming stars, galaxies, and galaxy clusters. Without this unseen structure, the visible universe would look very different and far less organized. Around most galaxies exists a vast, invisible structure that extends far beyond the bright stars and glowing gas. This structure cannot be seen directly, but its presence is inferred from how galaxies behave. Scientists describe this region as a halo. A halo is a roughly spherical volume of material that surrounds the visible parts of a galaxy, much larger than the region that produces light. Visible galaxies appear as bright disks or spirals when viewed through telescopes. These bright regions only represent a small fraction of their true size. Measurements of star motion show that gravitational influence continues far outside the visible edge. Stars and gas clouds near the outskirts move as if they are still deeply embedded in a larger mass. This behavior indicates that the surrounding halo contains most of the galaxy's total mass. An everyday example helps make this structure easier to imagine. Think of a city seen from above at night. Only the street lights and buildings are visible, forming bright patterns. Surrounding the city, however, there may be invisible infrastructure, such as underground tunnels, buried cables, and foundations. These hidden structures determine how the city functions, even though they cannot be seen from above. In the same way, the visible galaxy is only the bright surface, while the halo forms the hidden foundation. The natural phenomenon governing these halos is gravitational equilibrium. Gravitational equilibrium means that the inward pull of gravity is balanced by the outward motion of stars and gas. Without a massive halo, this balance could not be maintained. The visible matter alone does not provide enough gravity to keep the galaxy stable. On a cosmic scale, these halos are not small. They extend hundreds of thousands of light years beyond the visible edges of galaxies. Light years are a unit of distance that measure how far light travels in 1 year. These enormous halos overlap and interact, creating a connected structure across the universe. This invisible framework quietly shapes the placement and movement of galaxies, forming a stable architecture on scales far beyond human experience. Galaxies rotate in a way that reveals a hidden influence. When scientists measure the speed of stars orbiting around the center of a galaxy, they find a pattern that does not match what visible matter alone can explain. The expected pattern is based on everyday orbital motion. Objects farther from a central mass should move more slowly because the gravitational pull becomes weaker with distance. In reality, stars in the outer parts of galaxies move at nearly the same speed as stars closer to the center. This creates what scientists call a flat rotation curve. A rotation curve is a simple graph that shows how orbital speed changes with distance from the center. Instead of decreasing, the line stays almost level. This pattern has been observed in hundreds of spiral galaxies and shows remarkable consistency. A familiar daily comparison makes this behavior easier to understand. Think of a merry-go-round in a playground. If only the center were heavy, the outer horses would feel less pull and drift outward or slow down. If the ride somehow had hidden weight spread evenly throughout its whole structure, then the outer horses could move as steadily as the inner ones. In galaxies, the hidden mass acts like that evenly spread weight. The natural phenomenon behind this behavior lies in gravitational distribution. When mass is spread out in a wide, extended region, the gravitational effect does not drop off quickly with distance. Instead, it stays strong enough to keep outer stars moving at high and steady speeds. The visible stars and gas represent only the bright inner part of the system. The unseen mass dominates the gravitational field. The discovery of these flat rotation patterns was one of the strongest pieces of evidence that galaxies are embedded in massive, unseen structures. These structures control the motion of stars and shape the large-scale balance of galactic systems. Across distances measured in tens of thousands of light-years, this invisible influence quietly determines how fast galaxies spin and how stable they remain over billions of years. Light normally travels through space in straight lines. Under strong gravity, however, the path of light can bend. This bending does not happen because light has weight. It happens because massive objects curve the space around them. In simple terms, space itself becomes slightly warped, and light follows that curved path. This natural phenomenon is known as gravitational lensing, which means that gravity acts like a transparent lens. Astronomers first confirmed this effect during solar eclipse observations in the early 20th century. Starlight passing near the sun appeared slightly shifted from its normal position. This showed that mass could change the path of light. Over time, the same effect was observed on much larger scales. Galaxy clusters were found to bend the light of even more distant galaxies behind them. A simple, everyday example helps make this clearer. Imagine looking through a clear glass window that has uneven thickness. Objects seen through the thicker parts of the glass appear shifted or stretched. In space, heavy mass plays the role of that thicker glass. Light still travels freely, but its direction is altered by the curved structure of space around massive objects. The important detail is that the amount of bending reveals how much total mass is present. When visible stars and gas are counted, they cannot produce enough gravity to cause the strong lensing that is observed. This means additional, invisible mass must be present. Astronomers can map this hidden mass by measuring how strongly the background light is distorted. On cosmic scales, gravitational lensing has revealed giant, invisible structures connecting galaxies and clusters. These structures guide light and shape the visible universe in subtle ways. Light traveling for millions or even billions of years can be shifted, stretched, or multiplied into arcs and rings. This silent bending of light provides a direct visual trace of the unseen matter that fills space and quietly sculpts the large-scale structure of the universe. Dark matter is not spread evenly through space. It forms clumps, long streams, and enormous connected structures that stretch across the universe. These structures do not shine or glow, but their shape is revealed through the motion of visible matter. Galaxies tend to gather along these invisible paths, showing that an underlying framework is guiding their positions. The earlier stages of the universe were almost uniform, with only tiny differences in density. Over time, gravity amplified these small differences. Regions with slightly more mass began to pull pull in surrounding material. This process created growing concentrations of matter. Ordinary gas fell into these regions and eventually formed stars and galaxies. The invisible mass formed the initial scaffolding that made these patterns possible. A helpful everyday comparison is a spider web covered in morning mist. The threads of the web are usually invisible, but the mist reveals their shape. Leaves and small insects become trapped along the sticky lines, outlining the structure. In the universe, dark matter forms the hidden threads, and galaxies gather like droplets along these invisible paths. Scientists describe this pattern as a cosmic web. The cosmic web is a vast network of filaments, nodes, and empty regions. Filaments are long strands of matter. Nodes are dense intersections where galaxy clusters form. Between them lie large voids, which are regions with very little matter. These features arise naturally from the way gravity organizes matter over billions of years. On the largest scales, these structures span millions of light years. Light years are a measure of distance equal to how far light travels in 1 year. Along these immense filaments, dark matter streams slowly, guiding gas and dust into the regions where new stars and galaxies will eventually appear. This silent network gives the universe its large-scale texture and determines where structure can grow and where space remains almost empty. The universe appears empty when viewed with the naked eye, but on large scales it is filled with structure. Between stars, between galaxies, and across immense cosmic distances, there exists a silent landscape of matter that does not emit light. This hidden landscape is made visible only through its gravitational influence on the things that do shine. When astronomers map the universe, they do not only look for bright objects, they also track motion, bending of light, and subtle distortions in background radiation. These measurements reveal that much of the mass in the universe exists in regions that look completely dark. These regions are not chaotic. They form smooth, extended shapes that connect galaxy clusters and support the overall architecture of the cosmos. A simple everyday example can make this easier to picture. Imagine walking across a perfectly calm lake at night in a small boat. The surface looks smooth and empty. When the boat moves, gentle ripples appear, revealing that the water is always there, even when it looks still. In space, visible stars and galaxies are like the ripples. They reveal the presence of a vast, invisible background that supports their motion. This natural structure is governed by gravity acting over enormous distances. Gravity works silently, without light or sound. Large regions of invisible mass pull gently on visible matter, guiding how gas flows and where galaxies gather. Over billions of years, this slow influence creates stable patterns in the distribution of matter. On a cosmic scale, this silent landscape stretches across distances measured in millions of light years. The Milky Way itself sits inside one of these larger structures, moving slowly through a gravitational environment that cannot be seen but can be measured. This hidden terrain of mass forms the foundation of everything visible, acting as the quiet framework that gives shape and balance to the universe as a whole. The Milky Way did not form in empty space. Its birth was guided by an invisible structure that existed long before stars appeared. In the early universe, regions of dark matter began to gather under their own gravity. These regions formed dense centers that acted as gravitational wells, pulling in ordinary gas made of hydrogen and helium. As gas fell into these gravitational wells, it began to heat up and compress. This compression led to the formation of the first stars. Over time, many stars gathered into rotating systems, and these systems became the first galaxies. The Milky Way grew inside one of these invisible dark matter halos, which provided the gravitational stability needed for long-term structure. A simple, everyday comparison helps clarify this process. Imagine a bowl placed under a running tap. The bowl itself is invisible, but water collects in its shape. The final shape of the water depends entirely on the hidden form of the bowl. In the same way, visible matter collected inside dark matter structures, and the shape of galaxies followed the shape of these invisible gravitational containers. Natural cosmic processes worked slowly but steadily. Gravity pulled matter inward. Conservation of angular momentum caused the forming galaxy to begin rotating. Over billions of years, this rotation flattened the gas into a disk shape. Stars formed within this disk, creating spiral arms and a bright central core. Throughout this process, the dark matter halo remained mostly unchanged, continuing to provide a stable gravitational background. On a cosmic scale, the Milky Way is just one of billions of galaxies formed through this same pattern. Each galaxy sits inside a massive dark matter halo. These halos connect to larger structures, such as galaxy groups and clusters. The birth of the Milky Way was therefore not an isolated event. It was part of a much larger pattern, shaped by invisible mass, stretching across millions of light years and billions of years of cosmic history. The solar system exists in a very specific region of the Milky Way, and this location was not chosen at random. Long before the Sun formed, dark matter shaped the overall structure of our galaxy. A massive halo of invisible matter defined where gas would collect and where stars would eventually be born. As the Milky Way developed, dark matter created a stable gravitational environment. Ordinary gas settled into a rotating disk inside this invisible framework. Over time, pockets of gas became dense enough to collapse and form stars. The Sun was born inside one of these regions, not too close to the crowded galactic center, and not too far out in the sparse outer reaches. A simple daily comparison makes this easier to visualize. Imagine a large city built on invisible underground rails. Trains move along fixed paths that cannot be seen from the surface. Buildings and neighborhoods naturally grow around these stable routes. In space, the dark matter halo acts like those unseen rails, defining stable paths where stars and planetary systems are more likely to form. The natural phenomena involved include gravitational balance and orbital stability. Regions too close to the galactic center experience strong gravitational forces and frequent stellar collisions. Regions too far out have weaker gravitational binding and fewer heavy elements. The Sun formed in a middle zone where gravity was stable and where generations of earlier stars had already created heavier elements needed for planets. On a cosmic scale, this positioning allowed Earth to exist in a relatively calm region over billions of years. Violent events, such as frequent supernova explosions, were less common in this zone. This stable galactic environment, shaped indirectly by dark matter, made the long-term development of planetary systems and, eventually, life possible. The solar system's position is therefore part of a larger invisible design created by math that cannot be seen, but whose influence is constant. The large structures of the universe did not appear by chance. They were shaped by a hidden influence that worked like an architect, guiding where matter could gather and where empty space would remain. This architect was not a conscious force, but a natural process driven by invisible mass responding to gravity. In the early universe, dark matter began to form slightly denser regions than the surrounding space. These regions acted like gravitational anchors. Ordinary gas was slowly drawn into these anchors. Over long periods of time, the gas cooled and condensed, forming stars and galaxies. The visible universe grew by following the blueprint created by this unseen foundation. A simple everyday example makes this easier to imagine. Think of wet sand at a beach. If a hidden mold is pressed under the surface, the sand above it slowly takes on the shape of the mold. The surface looks natural, but an unseen structure has guided its form. In the universe, visible galaxies are like the surface of the sand, while dark matter provides the hidden mold. Natural cosmic forces worked patiently. Gravity pulled matter inward. Small differences in density became larger over time. This gradual process created filaments of galaxies, dense clusters, and vast empty voids. These patterns did not arise from light or heat, but from the slow influence of math that could not be seen directly. On a cosmic scale, this invisible architecture stretches across millions of light years. Galaxy clusters sit at the intersections of these structures, like cities at the crossings of major roads. The overall design of the universe, from single galaxies to giant superclusters, follows a structure laid down by dark matter. This unseen architect quietly determined the layout of everything visible in the cosmos. Galaxies could not have formed in a smooth, empty universe. Ordinary gas alone is too light and too slow to gather into stable structures by itself. A stronger gravitational foundation was needed to pull matter together and allow stars and galaxies to appear. This foundation was built by dark matter. In the early universe, dark matter began to clump together before ordinary matter could. Because it does not interact with light or heat, it cooled faster and collapsed more easily under gravity. These dense regions became gravitational wells. A gravitational well is a region where gravity is strong enough to pull surrounding material inward. Hydrogen and helium gas fell into these wells and began to collect. A simple daily comparison helps explain this process. Imagine flour slowly settling in a kitchen bowl. If the bowl is deep and wide, the flour naturally gathers in the center. If no bowl exists, the flour spreads thinly across the table. In space, dark matter created the deep bowl, and ordinary matter behaved like the flour, gathering where gravity was strongest. Natural cosmic processes then took over. As gas collected, it became denser and warmer due to compression. When the density and temperature became high enough, nuclear fusion began. Nuclear fusion is the process where light atoms are pressed together to form heavier atoms, releasing energy. This marked the birth of stars. Over long periods, groups of stars organized into rotating galaxies. On a cosmic scale, this process repeated everywhere. Without the hidden gravitational wells formed by dark matter, gas would have remained too spread out to create stars or galaxies. The visible universe, with its billions of galaxies and complex structures, exists because invisible matter provided the first stable framework. Dark matter did not shine, but it made all shining structures possible. Most of what appears real to human senses is made of visible matter. Stars, planets, oceans, and living organisms are built from atoms that interact with light. Beneath this visible layer, however, lies a much larger foundation that cannot be seen directly. This hidden foundation is formed by matter that reveals itself only through gravity. Scientists learned that visible structures sit on top of an invisible framework by comparing light with motion. When they mapped where light appeared in the universe and compared it with how objects moved, the visible layer proved to be incomplete. The underlying structure carried more mass and more influence than the bright layer on the surface. A simple everyday comparison helps clarify this idea. Imagine a city skyline reflected in a lake. The reflection shows the buildings, lights, and shapes. Beneath the surface of the water lies a solid lake bed made of rock and foil. The reflection can shift and ripple, but the lake bed remains steady and governs the water above it. In the universe, visible matter is like the reflection, while the hidden mass is like the solid ground beneath it. Natural cosmic processes depend on this invisible foundation. Gravity pulls normal matter into stable paths created by unseen math. Gas collects in these paths and forms stars. Stars gather into galaxies along this framework. Over billions of years, this underlying structure has remained stable, while visible objects have continuously formed, moved, and changed. On the scale of the universe, this hidden foundation stretches across vast distances measured in millions of light years. Galaxy groups and galaxy clusters are held in place by structures that cannot be photographed. The visible universe rests on this invisible base, the same way a forest rests on unseen soil and roots. Everything that can be seen is supported and shaped by what lies underneath, quiet, steady, and unseen. Despite a century of observations, a central mystery remains beyond direct reach. Instruments can track motion, measure light bending, and map large-scale structures. Yet the substance responsible for these effects still cannot be captured in a laboratory sample. This gap has become one of the deepest unresolved problems in modern physics. Early ideas attempted to explain the missing mass as faint stars, cold gas, or hidden clouds of dust. Each candidate was tested and gradually ruled out. These ordinary sources could not produce the consistent gravitational patterns seen across galaxies and clusters. The remaining possibility pointed toward a new form of matter that interacts very weakly with normal atoms. A familiar daily comparison helps clarify the challenge. Imagine trying to measure a slow underwater current using floating leaves. The leaves drift in steady patterns, showing that water is moving, yet the current itself cannot be held in your hands. In the same way, visible objects in space drift and rotate according to forces created by something that cannot be directly touched. Modern detectors now search for tiny energy signals deep underground and in space-based instruments. These devices are designed to detect rare collisions between invisible particles and ordinary atoms. So far, the signals remain uncertain or silent. This silence is not failure, it is information. It tells scientists where the invisible matter does not interact, narrowing the search. On a cosmic scale, this unanswered mystery shapes the future of physics. Solving it would not only explain galaxy motion, but also reveal new laws of nature. The unknown substance remains out of reach, yet its effects are written clearly across the structure of the universe, stretching over distances measured in millions of light years. Scientists are building new tools to search for matter that cannot be seen. These experiments are not based on taking pictures. They are based on measuring tiny movements of energy and subtle changes in atomic behavior. The goal is to detect extremely weak interactions between invisible particles and ordinary matter. One major approach places detectors deep underground. Thick layers of rock block cosmic radiation and background noise. This creates a quiet environment where rare events can be noticed. Inside these laboratories, large tanks of ultra-pure liquid are monitored by sensitive sensors. If an unseen particle passes through and touches an atom, it may produce a faint flash of light or a small vibration of energy. A daily comparison helps explain the idea. Imagine sitting in a silent room, trying to detect a gentle breeze by watching a hanging thread. Most of the time, the thread does not move. When it does move slightly, the air itself cannot be seen, but its effect becomes visible. The detectors operate in a similar way, waiting patiently for rare and subtle signals. Another method uses particle accelerators. These machines push particles to very high speeds and collide them together. Scientists study the debris created by these collisions. If unexpected energy seems to vanish, it may indicate that invisible particles carried it away. This absence becomes a form of evidence, showing that something unobserved was involved. On a cosmic scale, future space telescopes and observatories will continue to map gravitational effects across the universe. They will measure how light bends and how galaxies move with even greater precision. These future experiments are designed to slowly narrow the possibilities, bringing the invisible closer to being understood and tracing the hidden framework that shapes the universe across millions of light years. The universe is largely built upon things that cannot be seen. Stars and galaxies are the bright surface of a much larger structure. Beneath this surface exists a form of matter that does not emit light, yet provides most of the mass that holds everything together. The visible universe sits inside this invisible framework, like a thin layer of light on top of a massive foundation. When scientists measure the total mass of the universe, they find that normal matter makes up only a small portion. Most of the mass exists in this hidden form. This means that what humans can directly observe represents only a small fraction of what actually exists. The structure of the universe depends far more on the invisible than on the visible. A simple daily comparison helps clarify this idea. Imagine a tall building supported by a deep underground foundation. From the street, only the glass, metal, and concrete are visible. The massive concrete supports below ground cannot be seen, but they carry most of the weight. In the universe, Visible stars act like the upper floors, while the unseen mass acts like the foundation buried far below the surface. Natural laws operate according to total mass rather than visible mass. Gravity responds to everything that has mass, whether it shines or not. Because of this, the invisible matter quietly shapes the movement of galaxies and the distribution of cosmic structures. Gas clouds flow along paths defined by these unseen gravitational gradients, forming stars in stable regions. On a cosmic scale, this invisible framework stretches across distances measured in millions of light years. Entire superclusters of galaxies are arranged according to patterns defined by unseen mass. The universe is therefore not primarily constructed from light, but from something deeper and darker that provides the hidden structure on which everything visible is built. To understand the importance of invisible matter, scientists sometimes explore what would happen if it did not exist. Without this hidden mass, the universe would behave in a dramatically different way. The structures that now appear stable would slowly come apart under their own motion. Galaxies rely on extra gravitational pull to stay intact. If only visible matter were present, stars in the outer regions of galaxies would move too fast to remain bound. Over time, these stars would drift away into empty space. Spiral structures would dissolve, leaving behind scattered and loosely connected stars. A simple, everyday comparison helps visualize this change. Imagine a spinning wheel held together by strong internal supports. If those supports are removed, the spinning pieces would fly outward, the shape would collapse, and the system would lose its balance. In the universe, dark matter acts like those internal supports, keeping large systems stable. Galaxy clusters would face similar changes. Without enough gravitational binding, clusters of galaxies would slowly disperse. The cosmic web of filaments and nodes would fade because there would be no strong framework to hold it together. Gas would struggle to collect into dense regions where stars normally form. On a cosmic scale, the universe would become far more uniform and empty. Fewer galaxies would form, and those that did form would be fragile and short-lived. The rich structure seen today, with its clusters, filaments, and vast connected patterns, depends completely on the presence of this unseen mass. Without it, the visible universe would be flatter, quieter, and far less organized. Life exists inside a structure that cannot be seen. Galaxies, stars, and planets move through a gravitational environment shaped by invisible mass. This environment does not touch human senses directly, yet it determines the stability of the cosmic systems that make life possible. From the largest galaxy clusters down to the motion of a single star, gravitational forces guide every path. These forces come not only from visible matter, but from a much larger hidden component. Earth travels through this framework as the solar system orbits the center of the Milky Way. On even larger scales, the Milky Way itself moves within a network of unseen mass. A simple, everyday comparison helps clarify this idea. Imagine walking across a bridge covered by a thick layer of fog. The bridge surface can be felt with each step, but the structure below is hidden. Steel beams, cables, and foundations carry the real load. The visible surface is only a small part of the true structure. In the universe, visible matter is like the foggy surface, while the invisible mass is like the hidden framework beneath it. Natural processes unfold within this unseen structure. Gas flows along gravitational channels. Stars form inside invisible wells of mass. Over billions of years, galaxies gather where this framework is strongest. Nothing stands still. Everything moves within the gravitational boundaries set by matter that does not emit light. On a cosmic scale, humanity lives inside this invisible framework without ever directly seeing it. The night sky appears dark and quiet, but behind every star and every faint glow lies a vast structure holding everything in place. Existence itself unfolds inside a silent architecture of mass, shaping motion, time, and the long-term stability of the universe. This quiet story now comes to a pause. The universe continues its slow motion, steady and unseen. Stars drift, galaxies turn. Invisible structures hold everything in balance. There is nothing to solve here, only something to rest within. The visible world remains small, and the unseen world remains vast. Time moves gently forward, and the silent framework of the cosmos remains.